Um, Welcome to day 4 of the Mojaloop convening. We're going straight into our presentation. Today is a few technical updates and a few proof of concept presentations. So that's looking forward to that. We're starting off with Justus and Graham from Deloitte, South Africa on the Mojaloop fraud risk management playback. Over to you, Justus.
Hi, Asamin, and hi everybody from the community, and we're now the Mojaloop Foundation. It's nice to be back to present again on our fraud risk management work. I'm going to start right away, and just maybe a little bit of background for the people who aren't familiar with the work that we have done so far. We started back in PI8 with some work on to formulate the requirements and the context and the scope of a fraud risk management solution as a complement to the Mojaloop platform. And in our first PI, we delivered a typology register and a threat assessment using the Dread and Stride modeling. Typologies being the methods according to which fraud is perpetrated in a financial ecosystem. We also produced a data dictionary that cataloged all of the data that would be required to identify fraud and money laundering behavior. And we developed a business requirements document at the time that had all of the requirements that you would need in order to develop a fraud risk management solution on the Mojaloop platform. We also did some work around the key risk indicator dashboard, and we had a proof of concept that was partnered with SAS, where we presented how a solution would typically go about identifying fraud and money laundering within an ecosystem. We then took that work a little bit further into PI9 and developed a strategic assessment framework that would define how you would operate a fraud risk management platform within an ecosystem, the strategic drivers for that, how that solution might be paid for, or how the costs would be covered, and essentially what a solution like that would cost. We also added a lot more detail in the classification of the risk typologies. And in particular, we developed what we called the APRICOT model, which was used to classify the typologies at a very high level of detail in preparation for identifying the typologies that would be active within a specific ecosystem and its configuration, and then also how those typologies might be turned into rules. And we also took all of those typologies and identified very specifically all of the data requirements for each of those typologies. So to help a ecosystem identify what the data is that they would need in order to identify the specific typologies that would be active within that ecosystem. In PI10, at the end of PI9, we had a very ambitious list of outstanding requirements. About half of them related specifically to a build of a solution. But at the time, we are not a technical company specifically, so we don't have the capability to build that. And in the absence of a developer who was leading the charge on the build, we focused on wrapping up perhaps some of the more business-focused requirements. And in particular, one of those was a fraud risk management capability assessment. What that would mean is we would go out and do an assessment on a Mojaloop operator or a digital financial services provider, and then catalog all of the fraud risks and AML risks that that specific organization would be vulnerable to. In addition to that, we felt that it would be useful for the community to see what kind of commercial solutions are available to meet the fraud risk management requirements of a Mojaloop operator. And we had done an assessment of about 12 to 15 fraud risk management solution providers at a very high level, mind you, so not at quite the detailed level of an RFI, but we will get to that when we have a look at the vendor response. And we put together a bit of a comparison matrix of ultimately 8 vendors that we believe would be able to meet some, if not all, of the requirements of a fraud risk management solution within the Mojaloop network. So our presentation today focuses then on the capability assessment and the work that we've done there, and then also on the fraud risk management vendor analysis. And then finally, to conclude, we want to talk about what the next step should be, given everything that we have put together for the Mojaloop community to date over the last 8 months or so. What does that information mean, and what does that information allow you to do? And what then are the next steps for the Mojaloop community and the Mojaloop Foundation? I'm going to start then with the capability assessment, and maybe just a quick recap of the APRICOT model, which is the core driver of decision-making within the capability assessment. So we developed this APRICOT model as a number of dimensions that detailed the approach, the products and services that are involved, regulatory impact, involved parties, the channels, organizational scope and transactions of every single one of the risk typologies that we had cataloged in our risk database. In particular, then each of these dimensions would have a number of attributes that would be ascribed to each of those typologies. And when we started looking at the beginning of our program increment at these in a little bit more detail, one of the first things that we had to do towards operationalizing this APRICOT model was to just tweak it a little bit. So in some of the dimensions, the classification of the typologies weren't quite as detailed as we would have liked them to be. I'm going to go through these fairly quickly. I don't want to spend too much time on work that we had essentially presented previously. But one of the primary motivations around enhancing this model was to improve the discrimination between specific typologies. Some of the values and attributes that we had come up with in the past didn't allow for a high level of discrimination and fidelity related to some of the typologies, and some of the typologies were classified perhaps a little bit too close. And in particular, we wanted to provide a framework from which you can go directly into the rules development that you would need to do in order to drive the detection of these typologies within a solution. In particular, we wanted to move away from a relational database format and rather take up all of that white space that you would typically find in a relational database for not applicable or no values, and move into a graph database format, which would make it a lot easier to map to specific typologies as if they were fingerprints in a system. From that perspective, we'd enhanced the approach, moving away from we added we added some cardinality in the transactional values to determine whether or not a specific transaction needed multiple instances of transaction in order to detect, or whether or not a single transaction would be sufficient in order to identify either fraud or money laundering behavior in that transaction. And we also added time as a dimension up front in the approach. Are these transactions supposed to occur within a short time frame? Is it a longer time frame or a very specific time frame? What are the boundary time values for a specific typology? So for example, transactions that occur outside of traditional office hours may inherently carry some risk themselves. And also, even the measured tempo of a recurring frequency of some typologies may also give you an indication of fraud. We'd also had a look at the impacted parties and the way that we had originally classified those, and we decided to move away from just cataloging whether or not those impacted parties are involved in the process, but we decided to break it down into who is the person or entity or organization that is actually being affected by the typology. It could be an end user that is being defrauded. It could be a merchant, an agent, or a tax authority. Very rarely it would be an operator, and often sometimes it would be a DFSP. So who is the victim that is involved in the specific typology? We also broke the participants down a little bit better in terms of who is involved in every given transaction. And in the cases where there is no transaction involved, who is actually involved in the behavior that you would see around a specific typology. And then beyond that, who are the criminals? Where do they operate? And one of the things that we found we definitely needed to also include is where there is an imposter that has taken on the role of one of the legitimate participants in a specific transaction, and whether or not, even though the participant is behaving normally, that is not the real participant. And you typically find imposters on the customer end, or even in the case of merchants, or where there has been breaches in terms of system access or security. A imposter might actually even operate at the level of the DFSP or a potential Mojaloop operator itself. We also looked a little bit deeper at the country metrics for a specific typology. In particular, this relates more to how you would identify whether these typologies are active in a very specific ecosystem. We looked at knowyourcountry.com's modeling across country risk. They have a very transparent model and a weighted model that they have put together, and that model is frequently updated, and we decided it would be better to make use of something like that that is readily available than try and invent a country risk scoring model ourselves. So this country risk scoring model is now also considered in particular to identify the typologies that are in effect if you are performing transactions from low risk regions into potentially high risk regions. This isn't necessarily a sanction issue, but it's mostly related to regulatory arbitrage and the exploitation of the variances in regulations between specific regions. And then finally, we tweaked the organizational scope of the typology. Well, and finally, I think there's one slide after this. But in particular, what we wanted to identify here is what is the range of a specific typology across the entire network, starting with the payer and ultimately terminating with the payee. If there are agents, DFSPs, the hub operator, the DFSP again on the payee side, and the payee agent and potentially the payee. What is the range of a typology across your ecosystem? And then in particular, what is also quite important is the visibility of a typology and the risk to the individual players in the network. And in here, typically, we focused on the DFSP and the hub operator. And I think strategically, this is important to be able to determine whether or not the fraud risk management solution that you're going to implement should be focused on hub operations or on DFSP operations. There's always been an assumption that a DFSP would have their own fraud risk management capability, and then the hub would take care of those typologies that are only visible to the hub operator. But if we look at the split between the typologies and this visibility, there are actually very few typologies that are exclusively the domain of a hub operator. Most of our typologies are actually fall within the scope of detection for a DFSP. And I think when we talk a little bit later about what the next step should be, and also based on some of our strategic work before, what should the scope of an implementation of a fraud risk management solution for a Mojaloop operator look like, given that the bulk of the fraud is detectable by a DFSP and not the hub operator itself? Just one final thing here. We also looked at some of the participants in some of these typologies, and we identified a list of high-risk participants so that if, for example, any of these transactions terminate with any of these individuals or organizations or originate with some of these individuals, those transactions would be of greater concern from a fraud risk context. I spoke earlier a little bit about moving away from a relational database. So a relational database, if you think about it, is a lot like an Excel-based layout or database or format. And we wanted to move to a graph database layout. In particular, this would allow us to be a lot more flexible with how we extend the model and adding new classification attributes. It becomes quite easy in a graph context. But what we also want to be able to do is to easily identify certain things like if I and my DFSPs create a very specific footprint or a fingerprint for an ecosystem with a number of attributes from our ecosystem, it's much easier to map that ecosystem to all of the fraud risk typologies to identify which typologies a operator would be vulnerable to, which typologies a DFSP would be vulnerable to, and you could then catalog all of the typologies through their APRICOT profiles and ascribe an APRICOT profile to a specific DFSP or a switch operator. It would make it a lot easier to identify what your vulnerabilities are, and you could then extend this model over time to include all of the risk controls and processes that would be related to each of those typologies in assisting with the identification and the management of risk throughout your ecosystem. You would typically then get something like this, which would give you a fingerprint of a typology, and ultimately a collection of these typologies would be relevant to a specific financial ecosystem. And you know where you need to focus your efforts in terms of mitigating these kinds of risks. One of the things that we wanted to do that would assist us in populating the APRICOT model from the perspective of a Mojaloop hub operator or a digital financial services provider was a fraud risk management questionnaire, where we asked, we put together a very comprehensive document that asked in great detail information about the operations and the ecosystem within which a hub operator and the DFSPs operate. The idea behind this is to have a standardized and repeatable approach to evaluating your fraud responsibilities or your vulnerabilities. So from the Mojaloop community perspective, perhaps, or the implementation of a Mojaloop hub, you could give this questionnaire to a prospective hub operator and ask them to complete it. And that would then give you a sense of the vulnerabilities, the fraud vulnerabilities for that hub operator. A hub operator themselves can take this questionnaire to a DFSP and ask them to complete it so that they can understand the fraud risks that the DFSP introduces into the ecosystem, and that the hub operator then has to be aware of in order to be able to manage. Covered that. The things that we look at in the questionnaire, and I'm going to go over these very quickly. I realize that we don't have a lot of time for our session today. We look at the data availability. So in particular, we ask the Mojaloop hub operator and the DFSPs to identify all of the data that they have that's available that we know is necessary for the detection of specific fraud. The idea here is that if you collect or do not collect data that you need to detect certain fraud, then you are vulnerable to that fraud purely by virtue of the fact that you are unable to detect that fraud within your ecosystem. We also look at all of the products and services that are offered by the DFSPs, where the back end of those products and services result in transactions that flow through the Mojaloop network. And you'd be able to identify whether or not you are vulnerable to certain typologies. For example, a DFSP that specializes in or offers services in terms of commodities, securities, and trade financing products accounts for up to 19 different typologies that can be detected within the ecosystem. We also looked at regional presence and cross-border transaction flows, in particular where flows are from low risk to high risk countries, and we'd spoken about that earlier when we adapted our APRICOT model. And we also looked at where agents are used and how agents are used within an ecosystem if they are used. So if a DFSP has an agent network that signs up new customers and those agents are rewarded through commissions for those signups, that poses a fraud risk to the DFSP and the ecosystem at large. And then finally, we also catalog the kinds of customers that would be using the DFSP solution in order to transact through the system. What kinds of entities they are. Are you involved with investment brokerages, micro lenders, private individuals only? Do you have any non-resident foreign nationals or non-resident legal entities on your books? These are all important attributes to consider in trying to determine whether or not you are vulnerable to specific types of fraud. We have a little bit of additional work that we want to do in order to refine the model. Whether or not this forms part of a following program increment or not is, I suppose, up for discussion and the voting tomorrow. But this is certainly work that we intend to continue ourselves anyway. That would be more around the automation of the interpretation of the questionnaire results. So at the moment, it's very much a manual process to take those questionnaire results and then map them to specific typologies through the APRICOT model. We'd also like to test and calibrate this model against some real world results. And we have had some discussions with a couple of people around taking that to the next step and engaging directly then with some of the operators to be able to do that assessment on their behalf. That would then give them a sense of their vulnerabilities, but also allow us to calibrate and test our model in the real world. And finally, one of the last things we want to be able to do is to extend our model to say that if these are the typologies and the risks that we are able to identify, how should an organization approach and mitigate these risks? What are the controls that should typically be in place? Because it's not only just about having a system in place to detect a specific fraud risk or to do the investigation into those fraudsters, but you also talk about operational controls and operational processes. You need some sort of management structure that would deal with fraud risk within the organization. And we'd like to be able to do that, to take that to extend the model and the typologies to identify what those controls should be. For our second deliverable, we looked at some of the vendors, the dominant vendors in the market that are available to commercial solutions for fraud risk management and also fraud detection services, and in particular also money laundering. I just quickly want to take you through the selection criteria. So one of the things that we thought would be key in terms of determining the capabilities of a vendor would be their global presence, and in particular how close or how accessible the top countries are where we are looking at growing financial inclusion. In particular, we looked at the World Bank Group's Universal Financial Access by 2020 focus countries, of which there are 25. And those are the areas around which we would want to focus the vendors and their presence, and how easy it is then for them to access the services in those regions. Do they have local branches, partnerships, or staff in those regions, or do they only offer a remote service and deployment from a sort of a central hub in a different country? In addition to that, we highlighted several high-level requirements from the business requirement document that we'd compiled in PI8. And in particular, we focused on the data pipeline creation and management. We wanted to ensure that the vendors were capable of taking on data at high volumes through RESTful APIs, and also whether or not they had data streaming capabilities. We also looked at some performance metrics around their transactions per second and their turnaround time for evaluating a transaction based on their modeling that they do. Once data has been entered into the system, you would need a rules engine that would evaluate or model the transaction to determine whether or not that transaction contains any fraud or money laundering risk. We focused on whether there was a standard rules library where you could almost do certain fraud detection out of the box, and then whether or not that rules library was extensible through a configurable rules engine, and what the nature of that configuration would be. Do they have a rules builder in place, or is it almost a Excel formula-based kind of rules builder? We looked at whether some of the solutions specifically fraud-focused, but also AML capable. We found a mix of entities that provided a one-stop, all-inclusive solution for both fraud and AML, and obviously also the countering of financing of terrorism. And then some of the solutions were mostly AML focused, and some solutions were mostly fraud focused. So there was a fair mix of the different kinds of focuses of various platforms. And then we also wanted to focus almost exclusively on the transaction monitoring component of a fraud risk management solution. So we didn't, there's a large number of solutions in particular around the AML space where the focus is also on customer profiling, adverse media, the KYC processes that need to be followed in order to achieve compliance with all of the various regulatory regions. We wanted to focus more on transaction monitoring and being able to detect fraud and money laundering behavior from the transactions themselves without the related customer management processes that go with that. And then finally, we wanted to look at their case management capabilities. Is it roles-based? Are those roles configurable? Do they offer configurable workflows for various queues and channels, and assigning work to all of your financial services providers that would exist then under the periphery of the ecosystem that would ultimately be accountable for managing the fraud alerts? The access that those DFSPs would have to be through a browser-based kind of interface, and it would have to cater for multi-tenanted access. In addition to the high-level requirements, what we also did is we compiled a RFI template that could be used by a Mojaloop operator or perhaps even a DFSP to look at a more detailed view of the features and capabilities of a particular vendor and the solution that they provide. So for example, we had taken all of the requirements from the business requirement document and broken them into discrete requirement statements. And we had compiled this into an RFI template that the community can then use. And then a vendor would respond to each of these requirements, but whether they have a full compliance or partial compliance. Is this something that they're currently working on? Is it something that they have in the pipeline for future enhancement, or do they have no plans with any of these requirements at all? This RFI template will then be available to the community to use if they should look for a commercial solution for fraud risk management as part of Mojaloop. Our shortlist of solutions, essentially we went out and we looked at a number of different platforms. Some of the platforms were immediately apparently not suitable for what we wanted to achieve. But this is the shortlist that we found that may offer some value to the Mojaloop community. We looked at, I think more detail here, Caseware Alessa, Comply Vantage, FeedZai, ACI Proactive Risk Manager, and EastNet's Payment Card, 3i Infotech's AM Lock product, and then the SaaS Fraud Management Solution. Also looked at Brighterion AI. I'm going to give maybe a few highlights of our investigation across some of these. I just need to go to where I kept all my notes. We found with Caseware that they had great global reach, and it comes with an integrated rules builder that is capable of scripting in both Python and R, which makes it fairly open and easy to use. Comply Advantage was an interesting one. They offer a fully managed service from implementation and cloud-based hosting to ongoing management and maintenance support. So you wouldn't need to develop your own rules on the platform. They would do that on your behalf, but obviously that would come at a subscription fee or a maintenance fee. FeedZai offers, by far from what we had seen, the superior configurability of their data pipeline, as well as the detection rules. They had a very flexible rules engine with many configuration options, and their rules builder was very, very impressive. ACI Proactive Risk Manager also had great reach. They have a lot of presence throughout Africa, and in particular also in South Africa. Their product achieved a very high throughput in some of their operations, running up to 50,000 transactions per second. EastNet's Payment Card caters for ISO 20022 standard in the data ingestion, along with ticking all of the other boxes that we had for the data interface. This solution focuses specifically on fraud detection and prediction. They have a separate product that is focused on anti-money laundering. We looked mostly at the payment card product for our purposes here. 3i Infotech's AM Lock also has great global reach, but focused again more on compliance and AML monitoring, not on the typical fraud that you would want to pick up in the Mojaloop network. SAS, you may remember from the demo that they had given to us in PI8. They have a highly modular and componentized solution, great global reach. They are well familiar throughout Africa and Asia. The SAS solution is very strong on the data management and configuration of the data pipeline. They were one of the few solutions that we looked at that included entity resolution as part of the data pipeline. And we'll talk a little bit about the challenges of entity resolution in a minute. And their pipeline was perhaps not as automated in terms of configuring as some of the other solutions that we looked at. Brighterion AI is a MasterCard company, I suppose they are a subsidiary of MasterCard and perform all of the fraud risk management for MasterCard itself. They have significant experience and proficiency in a highly performant fraud detection with great global reach. They offer very close implementation and maintenance support, I think that perhaps speaks to their solution not being quite as configurable as some of the others, but they have a highly performant solution capable of up to 63,000 transactions per second in one of their installations. Some of the observations that we had from our evaluation, case management wasn't that big a differentiator. Almost universally, all of the solutions we looked at had great case management capabilities. Case management capabilities were integrated. You could access it through web browsers in a distributed fashion, set up your own queues and workflows, automated escalations and processes. So case management itself wasn't where the products differentiated themselves. Some products focused very much mostly on fraud, and some products focused mostly on money laundering. If an organization wanted to engage with the vendors, it would be essential to do a detailed analysis of the capabilities of these solutions based on your individual fraud risk management strategy to determine exactly what it is that you would use and what it is that you would need. Also, I think most of the solutions are focused more on the cold face of transactions and crime, and not necessarily on the transaction interchange. From that perspective, most of these solutions would probably be more suitable or more fitting within a DFSP environment rather than a hub operator environment. If we're looking at the range of features that most of these solutions come with out of the box, a hub operator will probably not use all of the features. And in a lot of cases, it would probably be overkill for an operator to acquire some of the commercial solutions that are available. As I mentioned briefly, entity resolution may be a challenge. What entity resolution means here is it's the product's ability to automatically derive a single view of their customer. So if, for example, you consider somebody is transacting through a operator in Tanzania, it's with their national ID information, but as soon as they cross the border into Kenya, they may be engaging with another operator through their passport number. And it's then very difficult to use a unique customer number from either of those systems to try and identify who that customer is. But entity resolution is a vital part of fraud risk management and fraud detection. So some of these solutions rely on almost pre-resolution or prefabrication of the single view of the customer, and they don't offer native entity resolution within the product. And that may be something to keep in mind when you are going out to look at some of these solutions from a commercial perspective. At the moment, I see we have a few minutes left just for us to close out. So we wanted to maybe just recap on the work that we had done for the community to date. In PI8, we had developed a business requirements document. We had developed a topologies database that highlighted all of the risks that a Mojaloop environment would be vulnerable to. And we developed a data dictionary that would catalog all of the data fields that you would need in order to effectively detect all of these typologies within a system. Ostensibly, that would then allow you to build a solution. The Mojaloop community could then invest in the development of the solution based on the requirements from the BRD and build rules that would cater for the typologies and build data pipelines that would cater for the data component. That was then at the end of PI8. During PI9, we went into greater detail in terms of if you don't want to build a solution or you don't need to build a solution that caters for all 232 risk typologies that we'd identified, that means that you don't need all of those data fields. And we developed the APRICOT model to help you discriminate between the typologies and the data requirements for a particular installation. We also conducted a strategic assessment and developed a strategic assessment framework and ultimately came up with a number of configuration options for a Mojaloop operator and how it might approach fraud within its ecosystem, depending on who its participants are. When we spoke about that, we looked at different kinds of models for the implementation, so that if you are going to be building your solution here, this is the framework within which you might want to operate that solution. For PI10, we took the BRD a step further and converted it into an RFI. And we also developed the questionnaire here that would allow you to derive the APRICOT model and the data requirements for a specific ecosystem. Just as some tools to help you understand your fraud risk management or your fraud risk exposure a little bit better. And in particular, if you wanted to acquire a commercial solution, here is an RFI that could assist you in that process. And we've also put together a list of vendors that you could potentially use. But ultimately at the moment, what that means is you have two options for executing fraud risk management within an ecosystem. You can either build one based on the business requirements that in the document and the strategic assessment framework and the typologies that we've put together, or you could procure a system based on the requirements and the associated solution design for a Mojaloop network. And I think from a next steps point of view, all of these tools that we have provided here would then be able to assist you in that decision once it's been made. But that brings us then to exactly what is that decision going to be. So from a next steps point of view, and maybe a question for the Mojaloop Foundation and the Mojaloop community at large, but also for the various Mojaloop operators that would like to implement the Mojaloop solution, is do you build a solution or do you buy a solution? If you are going to be building one, let's say from the perspective of the Mojaloop community or the Mojaloop Foundation, you would need to appoint a product owner that can drive and own and guide the development of a solution in line with the requirements for a solution as it exists within the Mojaloop context, within a Mojaloop ecosystem. You'd have to unpack the fraud risk management business requirement specification or document. You'd need to complete the solution architecture to make sure that the solutions are integrated into the Mojaloop platform. You'd have to plan and scope that development, put together the backlog, and all of this is work that should be driven by the product owner. And then you would need to go out and find somebody to help you build it and to secure the funding in order to drive that development. And then it's a question of developing and deploy. Out of everything in this list, developing and deploy is almost the easy one because you've done all of the hard work before that and the planning and the execution that takes into account. On the buy side, you would want to customize the RFI template to take it into account your own internal operations and your internal strategy. And you would want to determine the scope of that solution. Are you providing only for fraud, or are you also providing for an AML countering the financing of terrorism? What is the operating model within which you are going to conduct those activities? And then are you going to be managing fraud only for your entire ecosystem, including your digital financial services providers, or are you only going to be focused on fraud for transactions that passes through the hub that you then as an operator manage? You would then have to engage a number of vendors, review their solutions, select a couple of those solutions and go into an RFP process where you can talk about how much those solutions are actually going to cost you. And you would want to come up with the means to defray those costs, maybe sharing them with your DFSPs or still trying to stay true to the level 1 principles of inclusive financial access. And then finally, once you have picked a vendor, you would need to go into implementation. So from our perspective then, what this leaves the Mojaloop community with is this decision. What is next for the Mojaloop community? How are you going to drive the development or the provision of fraud risk management services or a solution across your foundation members and your community members? Are you going to build one or are you going to buy one? And I think ultimately that is a decision that has to rest with the community. Thank you. I can see Simeon looking at me anxiously. I think we are just about on time. I don't think that we have time for questions, but maybe one or two, Simeon?
I do see there are some questions that were dropped in the Q&A comments. Graham has answered a couple of them. So I'll allow you and Graham to respond to those. I do want to go to the next session because our next speaker has a hard stop. So sticking with the fraud risk management theme, I'd like to welcome Greg McCormick to make his presentation.
Great. Thank you very much, everybody.
Thanks, Justus. Greg, you're ready to go?
Yeah, give me just a second.
Sure.
The right screen here.
Okay. Yep, good
Okay,
to
this
go.
is going to be, you can see right now. This is going to be pretty quick. Just want to give a little bit of an update on what we're doing and where we're at. The title of this is OSS FRM. One of the things that I've been working on since we have joined the community is how do we make everything that Justus is talking about more affordable? How do we try to provide these services in a more flexible manner? So that's basically what this is about. First, I want to say thank you again to everybody. It's been nice to be part of the community. Everybody's been very helpful. We've really only managed to do a little bit so far. There's a lot of craziness going on right now as our parent company has us up for sale. So literally starting Friday every other day, I'm in investor meetings on stuff like that. Did a little bit of work on the performance side. We've done very little on the cross-border, but mostly I tried to focus on this. We jointly completed a proposal with Modusbox and some others for the Central Bank of Myanmar, and we wanted to thank Modusbox for inviting us to respond. We responded with the fraud portion and the dispute management portion on that. And we did actually complete the paperwork and everything for our Mojaloop Foundation membership, so we're actually happy that we've got that all done. I wanted to throw just a couple things out. I know that Justus and others have actually covered a little bit about this, but I wanted to put my take on it. So why OSS fraud risk management, or why am I interested in that? And that's because the cost of fraud and cyber attacks is estimated to exceed $3 trillion across the globe annually. This is one that's going to be of particular interest to us. There's a report that came from Interpol that says criminals are infiltrating Africa's booming mobile money industry pretty heavily. And the reality is with each technological leap forward, as far as what we provide, with each new convenience, it also brings new risks and new opportunities for fraud. So we need to make sure we're being very active in going after that. And what does that cost? I'm not going to go into great detail on this, but just an example, I found a fairly recent fine that went to Commerce Bank that was roughly 38 million pounds. And so if you could imagine a small DFSP trying to get something like that, it's just, one, it adds to the cost of the system to try to prepare to deal with that. It potentially puts them out of business. These requirements exist to protect the consumers, so we actually do need to have them. It's not like they're excessive or anything like that. So there's a lot of stuff going on in the industry right now. And as I look at all this, what are the trends, if you will, from solutions that need to exist to deal with this stuff? The reality is it needs to be easier. We need to do a better job of making these solutions easier to deal with. We also need to deal with the concept of scaling and sizing or pricing, right? Open source still costs money to implement, but we have to make these things affordable so we can push them out on the edge. If we've got peer-to-peer, mobile money, digital currencies, things like that, a lot of these issues occur on the edge of the system or where things are not as highly regulated. So I just finished closing a deal with a transfer company, and all they care about is the KYC AML requirements to make the regulator happy. They're not doing any fraud related stuff or anything like that because they just don't have it in their budget. So these are the types of things that we need to deal with. The other stuff that happens here is that the fraud management solutions, basically they're fragmented silos, right? So there's lots of different application areas. bigger organizations, this is very true, where you get these severe silos. So the reality is a holistic solution is needed, and we talked about this before, that everything from centralized data services to just shared and more affordable means of, let's say, validating an entity. How do we tie off between the local ID and a passport, or even a driver's license for that for that matter? So you need these centralized services, and the reality is I want to help solve these problems, much more affordably. So what is Cybrn doing to address the need? We're going to actually create a company that is focused on building an OSS fraud risk management solution. Cybrn's going to sponsor by donating some of the code and some of the techniques, staffing, infrastructure capability. We're also going to be seeking, obviously, others to participate, and we need to get organized around this. So I only just finally got the final bit of approval on how to do this 2 weeks ago. So we're still moving pretty quickly on that. We want to get started fast because there's a need. I've been being contacted on a regular basis about things where we can solve problems with this. And to be honest, I want to drive an MVP in 3 months, right? So that's extremely aggressive, but I'm also not going to spend a lot of time on the design time. What I'm going to do is I'm going to spend time reusing design patterns that we have that we're authorized to use for this in order to speed that up. And then we'll worry about what to do next, or maybe what to do right or get right, or let's say tweak it for Mojaloop in particular. So after that, we'll begin any sort of architectural changes or design changes. Generically, it's going to look something like this. I put Deno up there as the wrapper instead of Node, just because we have some interest in using TypeScript for that, but it could be either. We're going to have a user environment scenario, the admin, the case, the dashboards. This investigation wrapper is a component that will basically be able to push back and forth between different investigation suites should you need so. And then we're going to sit on top of an orchestration and rules layer that does have BPM in there, but I don't think we'll be using a lot of that except for pushing the cases around. The DMN rules engine will be there for final rules. And then we have something that we call a predicate builder that lets us do a lot of things very, very quickly and very effectively. And we'll leverage that as well. We want to use NiFi for managing data movement, the consolidation side. In our commercial product, we actually have our own layer for doing all the ETL work and things like that that's been built up over the years. But NiFi is quite good, especially the data governance side, so we know what's happened with that. Neo4j for the visualizations and investigative analysis. And the reason for that is the Neo4j Bloom, the desktop is open source. And so if we take a look at the investigative suite side, it's always been kind of a push-pull scenario. I'm usually pulling data from different sources, consolidating it, cleaning up, and then pushing into these analysis suites. We can actually get the same effect by pushing that into the desktop version, and then we save a lot of time. So again, my initial thought is, how do we get something that's actually functional within 3 months? And then we can worry about doing other things. So we've got NiFi for the data movement. I just threw down samples of like Cassandra or Mongo for the database. Like Justus was saying, I'm actually really fond of Neo4j in general, but Cassandra and Mongo also have very good graph capabilities or the integration with graph databases. So that's something that needs to be looked at, but they are not SQL in structure. So I definitely agree, NoSQL is the way to go with that. And then we've traditionally used Redis for a cache DB. There's a lot of pre-pipeline aggregation work that we do and how we do things, and we need a cache to deal with something like that. So then we're going to be worried about the connectors on like, say, Mojaloop and different payments hubs, banking and lending. We have a lot of integrations in other systems that exist, and we need to build the stuff So how do we basically build a listener that is monitoring the transactions and will work with the predicate builder to deal with the appropriate query structure, pull these things in and get them processed. I don't think for this, at least for definitely a first version, I don't think we need a CEP or complex event processing. And the reason being is the likelihood that people are using just Mojaloop, in my mind, is probably not going to be that high, and we don't want to make another silo. There are definitely going to be some that are like that, but the reality is you know, putting Kafka in as the main engine just to talk to all these other systems could be relatively complex, and I want to keep it simple. Obviously open to lots of discussion on that, and I'm sure that will happen. But this is where we think we want to go with this right now. And then next steps are, we need to identify who wants to do this with us, who are the participants, finalize the organization. We need to start up and bootstrap this situation. And we are already starting on the MVP process. Like I said, we have a mission to drive something quickly that can solve some problems. And then we'll worry about directional decisions, or we can start worrying about that. We want to get that MVP out so that it's useful, because frankly, I've got about a half a dozen people that are in need of using something like this. And then the continuity planning, how do we give this thing life, and what do we do? So that's basically what we're hoping to do. And I've only talked with a few of you about this. So any questions? And I think we're going to wind up with a lot of follow-up at some point, but this is where we're going. So like I said, quick, simple, and easy.
Thanks so much, Greg. We do have a few minutes left in this session. So Greg, are you going to hang out with us for a bit to answer any questions and see if we can take those?
Yeah, absolutely. I can definitely do that. Like I said, I wanted to get through this relatively quick. So
awesome.
I'll hopefully give you some time back.
I would appreciate that. I will also open up to questions from Justus's session. So we can take both of those right now. If you want to type it in the chat or in the Q&A, we can do that now. If not, I see Steve and Jose are already on the panel, so we can also go ahead with the session next. Any questions? All right. I don't see any questions. So thanks so much, Greg, and Justus for that, those presentations on the FRM. I will move on, see if we can try and get ahead of time here. I see Steve, Bristow, and Jose Moreno talking about Mojaloop, the recommended architectural practice for infrastructure deployment. Steve, you guys ready to go?
One moment, please.
Sure, that's fine. I see you, Jose, as well. And just as a reminder for everyone, all these sessions have, on our community forum on Discourse, we have different threads for all these sessions. So if you have questions now or at any point in the future, feel free to go to community.mojaloop.io and just plug in your thoughts there. I will keep an eye out for that, and I will ping the session panelists to respond as and when is required. Steve, Jose, take it away.
Hi, everyone. Yep, here to talk about the recommended architectural practice for infrastructure deployment, as it says on the screen. I intend to keep this as high level as possible because I know how exciting infrastructure is for everybody. And I'll probably be doing it at some pace because we've got quite a bit to get through. So hang in there, and please do feel free to review the recording afterwards. I'm open to any questions when we get to the end of it. So thank you very much. My name is Steve Bristow. I've got 10 years experience in finance and banking, building on-prem hybrid clouds, virtualization. I've got a real love for synthesizers and physical technology and repairing them. And there's a vicious rumor going around that I have a private cloud in the garage. Jose, would you like to introduce yourself?
Yeah, absolutely. Thank you. Yeah, so Jose Moreno, my name. I'm working in Microsoft for an organization called Fast Track for Azure. Our job is essentially helping customers getting their workloads to Azure to make that in the most efficient possible way. 20 years in the experience in the IT world, so longer than I care to admit. Yeah, father of two, living in Munich with my wife, my 2 kids, and 2 cats.
Thanks, Jose. So we're all familiar with the concept of the monolithic application. Nobody can see what's inside it. Everybody's watching it. Nobody's sure how it stays up. Everybody's scared to touch it in case it falls or fails in this case. And there are always forklift upgrades, big boxes that need shifting around. Microservices, containerized applications give us a way to get around this by turning each component of that application into a much smaller container that can be removed and replaced and upgraded without disrupting any of the others. It's relatively easy to inspect what's inside each one. They can be decommissioned, removed to save resources, or spawned dynamically. This makes it far more portable. You can wheel it around in the picture than a monolithic application. What this also does is enables us to use CI/CD to drive the application itself. CI/CD is continuous integration, continuous deployment. I know it's been spoken about elsewhere in this presentation, so I won't bore you too much with it, but it's a set of principles for getting an application from, it's a set of principles to deliver improvements to a business application with minimum possible disruption at regular intervals. How is that done? Well, there are 4 sort of high-level stages to the process, as you probably already know: development, testing, staging, and production. Testing can be a multitude of things. I know we favor more environments than just chucking it into test and have those discreetly. Likewise, staging can be multiple things. Production tends to only be the one for most people. As you can see the pipeline, stuff gets created in the development tier, functions, new features, functions, and optimization, performance, and security, and go through each of the subsequent environments for testing. Should it fail at any point, it goes back to the developers, back to the guys who create it, the code gets amended, and then it goes through the process again. You would hope that it would not happen in production, which is why there is a dotted line there. How does it actually get there? You need a repository. You need a central location that code can be pulled from to each of those environments, which is shown by these grey blocks here. The code repository holds all these assets for the apps. It controls versioning of each asset and creates releases to match specific object versions to specific versions of the overall switch. This means you can have approvals for deployment, stopping stuff from leaking out from one environment to another one, and gated tests. So if it fails the test, it simply cannot get out of that environment. It gets stuck there until it's been remediated. Significantly, we'd like to describe infrastructure as code. What does that mean? What does that do for us? Well, more often than not, you have conversations with engineers talking about the servers not being set up the same. We can't test a new version of the application until we can find some servers to build a new test environment for the new dependencies. Oh, it worked in test, but we found the production firewall wasn't set up the same. The classic example is an engineer saying, I just need to log into it to have a look at how it's currently set up. Or an auditor saying, oh, we need evidence that all of a set of things X are the same in production. So infrastructure as code helps us alleviate that by describing items like DNS, load balancing, storage, firewall, servers, networks, and Kubernetes pods and applications all as code, which means that the infrastructure that you build in development can be tested and staged before it gets to production, which gives you repeatability of each environment again and again where it's deployed. It gives you idempotency in that you can redeploy and redeploy on the same thing, and only the changed components will be removed or added. Firewall rules, pods, each thing is completely and utterly idempotent, and it removes any ad hoc changes as well. So if somebody comes along, changes something, maybe comes up with a fix, at the end of it you can say, brilliant, capture that, and then back you go to the declared state. It also gives you reliability and auditability. The single point of truth becomes the code for everything. This accelerates your delivery. Features, changes, enhancements, everything happens as fast as your business can test them. So what does that mean for infrastructure practice? To create a recommended infrastructure, we had specific design objectives. We wanted to achieve simplicity. That means less infrastructure layers. We wanted to keep as much as possible within the Kubernetes layer because it's highly code-centric, and drive things with policies rather than by building stuff and then trying to capture it in documentation afterwards. Security is a part of everything we do. So we want to segregate execution spaces to prevent CPU execution style vulnerabilities like Spectre and Meltdown. We want to control the network access footprint, and we want to keep all this development and security as far left in that pipeline as possible. We also want to keep node sizes sensible, consolidate workloads onto a fewer VMs because both of these are extremely cost-centric, and we want to minimize functionality outside of K8S, as I alluded to earlier. And of course, we want to share everything with the community. We've selected components based on a fairly complicated process I won't go into, but we've arrived at using Ambassador as an ingress. GitLab, many of our customers are already using it, but GitLab is the pipeline of choice. Not only is it your code repository, it runs the pipeline. It's really easy to start off with. Low barrier to access is key. And of course, it uses Git, which is an industry-accepted means of doing so. WireGuard is a turbocharged VPN solution, by far and away the fastest I think we've ever evaluated. And significantly, it's baked into the Linux kernel and highly programmatically configured. KeyCloak is an identity management solution I'll talk about shortly, and also Vault, which we're coupling with KeyCloak, is a means of storing secrets, keys, certificates, and all the stuff associated with an identity. Again, the EFK stack has been alluded to elsewhere into this, so I won't go into too much detail about why it's been selected, and the same with Grafana and Prometheus. It's widely regarded as industry standard. KeyCloak allows a user approaching the system to be provided with an appropriate role for their identity. So should that user be, for example, a developer, and they wish to access GitLab, they will be granted read-write access to that. Meanwhile, they will only have read-only access to the various Kubernetes clusters and dashboards. They might have write access to the development cluster. Should they want more access than this, they will have to request it. Equally, a tech support person approaching the platform will have the ability to configure and manage dashboards and alerts in Grafana and Kibana, but may not have read or write access to various different clusters. This is entirely configurable for each customer. It's not hard and fast rules. We can provide guidance on those, but it does mean that you are not managing identities in multiple environments. Nobody wants more than one login, ideally. The next part of the solution is global load balancing. So a switch running in an environment is great, but if you have a regional failure in public cloud, for example, you may wish to create the switch in another region. To do that using manual technologies is very hard. Global load balancing offsets that. It gives you anycast is one option, which is a static IP address or addresses for the platform that's advertised to different locations on the internet. Both AWS and Azure have products that allow you to do this. You've got Global Accelerator or Front Door. And on premises, if you're deploying there, you can use BGP as long as you arrange to do so with your service provider. The main benefit of this is the response to changes is instant. Should you lose a part of your infrastructure, BGP will reconverge very, very quickly. You can also use it as part of a wider load balancing scheme and for network equal cost multipathing. Far more appropriate on-prem than in the public cloud, but nevertheless, very, very useful to have. The alternative, which a lot of deployments are already on, is DNS redirection. On AWS, this is Route 53. In Azure, this is Traffic Manager. Much harder to do on-prem because you don't own DNS servers. It's a slower failover. Really, you don't want to reduce your DNS TTLs too low, or you'll have sessions timing out and all sorts of bad stuff going on. So generally, you're looking at a much higher failover time for a DNS reconvergence, but still feasible. Behind that global load balancer, we then move to the ingress, which removes WSO2 and replaces it with Ambassador API. Why? Well, it's faster, it's more lightweight, it's far more programmatically configured, which means we can deploy it more quickly and with less complexity, and it integrates into Kubernetes in a much more transparent fashion. It adds OAuth using KeyCloak, as you can see, to identify the correct level of access permissions for a call. It's cloud-native technology. The other component we're looking at but have yet to arrive on a solution for is service mesh. There's a number of competing options out there, and we're still currently testing these. The secure service-to-service communication they provide is essential. This is a step towards zero trust networking, where every communication between each component is encrypted. It also allows us to adopt micro-segmentation, which is effectively a firewall for every single service running that's configured by policy. As you can see from the diagram, which isn't a Mojaloop switch, this is a slightly larger environment, you end up with an awful lot of component-to-component connections. You wouldn't want to manage those firewall rules manually, so policy-based or baked into each of those pods is significant. And of course, it improves observability. You've got tools like Zipkins that enable you to view what is going on the network and audit that network configuration for security purposes. As alluded to earlier, workload separation is an issue. The idea of keeping an edge workload running on the same CPU as something highly secure with user data in it doesn't sit well in the current climate of Spectre and Meltdown and other CPU-based execution vulnerabilities. So anti-affinity rules are key here in Kubernetes. And what these enable you to do is to tell a workload which other workloads it shouldn't coexist with. And it's defined at a workload level. So should you only have one host and wish to build a development environment, these workloads can be preferred apart. So if there are enough hosts, they will go to those hosts. But otherwise, if there is no space to do so, they will all coexist together. This allows for much more dynamic scaling of an environment. Should you be able to add more hosts and then just hit the redeploy button, pods will move apart from each other. So again, it's great for scalability, flexibility, but ultimately there is a policy in place that tries to aim for the best level of security possible. There's 3 cohorts involved: a cohort of non-critical workloads for monitoring and so on and so forth. The hub enclave cohort is the golden fleece, as it were. It's got all the secrets and user data stored in it, and needs to be as far away from the edge cohort as possible, which is anything with an interface pointing outwards. As I say, preferences are key to these workloads being separate unless they don't have a choice. The other way to drive value is to ensure pods are running on optimal hardware. This doesn't always mean the biggest. In fact, for some of these workloads, it means the smallest. T3 extra large VMs, for example, running Kubernetes are a highly bursty CPU, but a very, very cheap platform. So Grafana, Kibana, and so on can run on 2 nodes in each availability zone on those. Likewise, the scale out and high performance components, we have the barest minimum running on high performance, as they are the most expensive, with other components existing in the scale out cluster. As you can see, there's a minimum number of nodes for each availability zone. This is significantly less than previous iterations of this. This slide also introduces the concept of the MAD, which we'll get to in a minute. Likewise, here's the same thing that José has helped us put together for Azure. Again, machine standard burst mode machines chosen as standard for the value tier, ensuring maximum value return on stuff that doesn't run at 100% CPU all the time, and larger nodes used for each performance tier. Also notice the managed services at the back end of this diagram. So what is the MAD, the MAD? This shows 2 environments with their own managed services deployed in AWS. Each one has their own node pools, and each one has their own anti-affinity groups. Nothing coexists. These are separate Kubernetes clusters. What that would normally mean is lots and lots of logins between each environment. However, as we've seen, we've adopted Keycloak to try and limit that. So we've also adopted the MAD domain, or monitor, administer, and deploy. This reduces the painful overhead of managing multiple identities. A single Keycloak instance can be used to access any part of the infrastructure with appropriate permissions. It also brings monitoring and alerting for logs and for metrics forward. What this means is a single pane of glass for operational staff to view the environments. It also means one place for alerts. You can simply define 1, 2, or 3 different levels of alerting for the different environment types, and then associate those with those groups as they get deployed, and alerts go out or not as appropriate. Nobody wants to be woken up at 4 in the morning because the development environment is running slow. It also gives us our centralized code repository and a VPN access into this management area. Availability zones are very popular in public cloud and are of significant importance to the operation of the switch. AWS and Azure both define regions as groups of availability zones with latency between those availability zones less than 2 milliseconds. This is much harder on premises, which is what I've shown, where you need to ensure that you've got something incredibly fast and low latency like dark fiber between each of those entities, each of those data centers. The other significant part of using availability zones is the assumption that one of them will fail. Certainly on-prem, we tend to lead towards the idea that each availability zone needs to be able to cope with 66% of the full production workload, meaning that you can lose 1 or 2 of them without having a significant impact. That factor also means that you can run other environments in those availability zones, and if you were to lose 2 of them, then you have the benefit of switching off those lower tier environments to keep production running. Again, AWS defines an availability zone with having unique layer 3 subnets. Azure allows you to stretch those subnets. On premises, you can do both. VXLAN technologies allow us to create layer 2 stretches as long as we get the underlying metro network correct. As you may have seen on the previous slide, there was a 25-kilometer limit to those links, which we'll touch on in a moment. Databases and replication. So as we stand at the moment, databases are a limitation to how fast the switch can go. In Azure, there are no multi-master instances of standards compliant MySQL. Any multi-master solution has a wrapper around it. Azure don't offer this. They've stayed standards compliant, and they use a series of replicas to achieve a 99.99% SLA. So that's 4 minutes and 22 seconds of outage a month, which may or may not be tolerable to a customer. AWS RDS is the cheap option from AWS with only a 99.95 SLA. If you need the more expensive one, they do have a multi-master replicated solution, which is, again, compliant with 4 nines SLA, but at nearly double the cost. Why is a 25-kilometer link, and why is database replication significant, or in fact any replication, not just in the database tier? Well, the worst case scenario can be exhibited by setting the max number of database concurrent operations to 1. If you've got a target of doing 300 database operations per second, that means you've got 0.3 milliseconds to complete each of those operations. If they're all writes and they're all commits, and you've got a 0.25 millisecond round trip time on the link between your data centers, then you only have 0.05 milliseconds remaining to process everything else. That's cutting it pretty fine. Realistically, most of these environments aren't going to be single-threaded. Database partitioning, structure, and indeed whether you can move those loads to other parts of the system mean that this can be mitigated. But fundamentally, there is still that limitation. It's also worth noting that any public cloud provider can only guarantee you 2 milliseconds of latency. Maybe lower, but they will only guarantee you those 2 milliseconds. On Percona DB, which is the preferred on-site replication technology for databases, most customers would probably want casual reads disabled. And what that means is that a replica of the database will not serve a read request that is stale. The consequence of that means that the whole cluster can only move at the speed of the slowest server that will certify that commit. If the commit cannot be certified within the timeout, the transaction will be failed for the end user. This means a slow network means a lot of failed transactions. So there are design considerations around database technology that can't be avoided. Moving on to event logging and management. Logs are collected from each environment by a FluentD exporter. These are then sent to a new Kafka cluster, not the transactional one, which persists those messages for us, meaning that even if the Elasticsearch database is under load because of a query or because of a search or something else, those log messages, which are, let's all face it, quite important for your next audit, are all baked into that database ready to be audited. This includes changes from the cloud monitoring platform, such as administrative changes to VMs, as well as environmental changes from configuration point of view and application logs. The Kibana dashboard is used for querying and generating alerts from the platform. Performance and metrics are much the same environment. Exporters run in each environment and forward the performance data and metrics to a Prometheus instance in the MAD. Grafana is used as a dashboard and for sending off alerts, and again, cloud metrics are harvested and added into that. This has the massive benefit of when you've got a performance issue or associated problem, you can start digging down into historical data, not only from your platform, whether it was redeployed or not, but also from the other environments to see how they behaved in test and in performance testing, staging, and so on and so forth. It's a very valuable repository of data. Unfortunately, it tends to be quite small. So with that in mind, I shall hand over to José, who's been looking at optimizing this design for an Azure architecture.
Excellent, thank you, Steve. Can you hear me?
I can.
Fantastic. Okay, so yeah, let's move to the next slide. The obvious question that we ask ourselves is: all right, we have this design, we have design the architecture so that it's cloud agnostic. And we have different environments, right? Some of them like development, where we don't want to spend that much. We just want to have enough performance to test the application. And the performance environment will, the production environment, where obviously performance and availability are key. How can we combine that in Azure, maintaining the cloud agnosticity that we've been advocating with the previous design decisions, and at the same time reap the benefits of public cloud? And that's what we are going to try to illustrate in the next few slides. So if you go to the next slide, we can see one possible approach of achieving this. On the left-hand side, where you see those services and containers, those are the two parts of the CI/CD, of the continuous integration, continuous deployment pipeline that will deploy the application. The top row, it will deploy the required services, be it on public cloud or on private cloud, so that then the application can work on those services. The lower row, where it says containers, it will deploy those containers in the Kubernetes clusters where the Mojaloop switch application will be executing. As you can see, there could be different combinations depending on whether you are creating a development environment or a production environment. Like, for example, in a deployment environment, you might want to have the data tier, meaning the Kafka and MySQL components inside of your Kubernetes cluster for cost reasons. However, in the production environment, looking at the right-hand side of the slide, you might want to leverage cloud native offerings like for example, some Kafka managed solutions or MySQL managed solutions that public clouds such as Azure or the AWS offer. In that case, what is absolutely critical is that the Mojaloop switch components do not have to be modified, and they can work the same whether that database, that MySQL database, that Kafka instance is running inside of the cluster or as a managed service. Another very critical part is that the services deployment is following a consistent framework, no matter whether you're deploying on premises or on public cloud. The framework that we are going to use is Terraform. So with Azure, all of the services involved in the Mojaloop design support a Terraform API, so they can be deployed for these possible combinations using that Terraform. In essence, here this picture should show a summary of what we try to achieve, getting the best of both worlds of cloud agnosticity and the benefits of public cloud. And now if we move on to the next slide, we can see two examples. So actually, this is the first example of a development environment and what it could look like in Azure. So we can start digging into those design decisions that Steve showed us in the first part of the presentation and what they mean for Azure. So in this design, the first thing that you might notice is that the Kubernetes cluster is actually one what we call Azure Kubernetes Service cluster in Azure, which is a managed Kubernetes offering. This has the benefit of cost because the master nodes are not paid by the customer, but they are paid and maintained by Microsoft, and has the benefit of being totally compatible with the upstream version of Kubernetes. Well, actually, it's the same thing, right? It's just the Kubernetes open source, but where the customer only pays for the worker nodes, and with a great integration with the rest of Azure services. So this is the first thing that the first recommendation that we have for Azure. You can see as well there the representation of the node pools that Steve mentioned before, having two different node pools with two different virtual machine sizes, one for the database elements and another one for the rest of the elements, where those anti-affinity rules can be configured. You can see as well that that's supposed to mean the different two colors, by the way, violet and green, where the different components are stored. And you can see that in this development environment, the databases are running inside of the cluster for cost efficiency. This could be constrained to a single availability zone in Azure. This could be stretched over up to 3 availability zones in Azure, depending on the level of resiliency that this single environment might have. On the right, we see the MAD, the management cluster, with some components, including VPN, GitLab, and others. And below, you see certain cloud-native management components that will have to be integrated with the Mojaloop management cluster, more specifically with the log and the metrics management systems, being Prometheus and Grafana, respectively. Okay, but since we are going to double click on that on a later slide, we can move on to the next slide where we can see a very similar picture, but for a production environment. In this case, the main difference is that the data components, meaning Kafka and Azure data and the MySQL database, are not deployed inside of the Kubernetes cluster, but they are deployed as a managed components. In this case, using Kafka on HD Insight on Azure. By the way, an alternative might be using Kafka on Azure Event Hubs, subject to evaluate. Could be depending on each customer implementation. The main point here is the application living in the Kubernetes cluster doesn't even realize that it's talking to an Azure service because the Kafka API stays absolutely the same. Same thing for MySQL database. If running inside of a managed service like Azure Database for MySQL, Microsoft will take care about all those SLAs, that 99.99% SLA that Steve mentioned previously. Right, and the rest of the Azure stuff would stay the same, that monitoring and security platforms that we can see now how they integrate with the management cluster. Right, so if we move on to the next slide, this shows us the integration between the native platform for logging and for and the management cluster being Prometheus here. The camera, this is in my way. Let me minimize this. Exactly, I can see. This is a very similar picture to the one that Steve showed before. The main difference is below. You can see in orange some Azure specific components. The most important one being the Azure Event Hub. This is an Azure service that collects logs coming from different sources, including some native Azure offerings. That could imply, for example, collecting some of those logs from the native offering for MySQL. That could mean getting logs from the master nodes from Azure, which are not managed by the customer, but by Microsoft. And the goal of this integration is this Event Hub would send the logs to Elasticsearch via some native integration that Elasticsearch is offering with Azure. And hence, on this Elasticsearch platform in the MAD, you would have all the logs, both those coming from the application itself, as well as those coming from the platform, in this case, Azure. If we move on to the next slide, we will see something very similar, but this time for metrics, not for logs, where Azure Monitor, which is the native component in Azure that is managing the metrics from different Azure services, will send those metrics to Prometheus so that Prometheus can export them, and they are accessible by operators in a consolidated manner. So operators do not need to look at a screen for the state of the application and another screen for the state of the Azure platform, but everything would be consolidated in the same Grafana dashboards. Okay, so we have, if we move on to the next slide, we have looked at the possibility of using some of those services. Here, a bit of a double click on the availability of the Azure database for MySQL offering, and most more concretely on the higher availability that Microsoft is offering here. Steve mentioned it's 4 nines of availability. And there, right, if something happened here, Microsoft would do the failover transparently without the user having to do anything about it. And that's one of the reasons why we normally recommend using this, just to alleviate the management overhead that creating your own cluster and managing your own availability would imply. All right, but this is inside of one single region. And remember, our region is a collection of availability zones. What happens if the whole region has a problem? And we would be talking here about a major disaster, right? So if we go to the next slide, we would see the steps that a recovery from a complete regional outage would imply. And by the way, though unlikely, we do recommend having a contingency plan that covers such a situation. Could be because of a major outage in Microsoft infrastructure, could be because of some political instability. Those might be reasons that might drive you to move the application to a different region. You would have 3 steps. The first one would be deploying the infrastructure that doesn't have any state automatically, programmatically, using the CI/CD pipelines that we've been seeing over Terraform. The second step would be restoring the data that you had in the previous region. And this is the main factor that is going to influence your recovery point objective. In other words, how much time, how many transactions are going to get lost, right? Because as Steve said, that synchronization is not going to be synchronous. It's going to, if there's a major event happening, chances are that some data is lost. The question is how long. And that number should be as close to 0 as possible. All right. One possibility is configuring regular backups on the database, and this is as well offered by the native offering in Azure, by the managed offering Azure database for MySQL, and having those database backups replicated across regions. Those backups are taken every hour. So in the worst case, if the outage happened right before taking the backup, you would be losing 1 hour of transactions, which is typically not acceptable by many customers. The good thing about this process is that it's very cheap, because the only thing you are consuming is storage for your backups. The second alternative, which offers a much lower recovery point objective, is having read replicas in the secondary region. Every transaction in the primary region would be sent to the secondary region asynchronously, so that any latency will not impact on the performance that the end user is seeing. The recovery point objective, the lag that we could, or the amount of data that could be lost in case of such an unlikely event like a regional disaster, might be seconds or single-digit minutes. It's hard to find to commit a number here, because it depends on many things, like how much data how much transactions, how many transactions are being sent to the database, the latency between both regions, right? If we're replicating between Africa and Europe, for example, that might be a different number that if we are replicating between 2 regions in Africa. Right. So, but in any case, much better than the backup-based solution. So this is the disaster recovery technology that we would recommend for databases. And then once the stateless and the stateful services have been restored in the secondary region, the last bit is using global load balancing, as Steve as well described, either DNS-based or Anycast-based, so that customers are now sent to the secondary region and not anymore to the failed region. For that, Azure offers 2 components, Azure Front Door and Azure Traffic Manager. Steve already described that they are using different technologies, and the requirements to use one or the other would probably depend on the individual customer requirements. Both work, and both are recommended solutions from a Microsoft perspective. And with that, we would finish the most important recommendations that we have for Azure designs.
Thanks, Jose. So something Jose alluded to there was recovering these environments quickly, and for that we need the accelerated power of infrastructure as code. So with all these objectives in mind, we needed to set about creating the latest version of IAC. So the story so far on this one is that we had version 1 of IAC, which was used by, I believe, Mawali, and the objective was to create a performant, highly available Mojaloop switch in Azure, which consisted of 3 or more environments. The redeployment of anything was a fairly big deal due to the heavy reliance on shell scripting. It's a highly sequential deployment and not especially declarative. Typically, we'd see an end-to-end deployment time of around about 14 days if you count snagging, fixing, and documentation and everything else. Which isn't great. It's not bad, it's not great. We then started building IAC v2, which was effectively the same thing on AWS. Again, the deployment time was much the same, but we were able to improve the reliability of deployments by removing pfSense and replacing it with HA proxy. However, it's still a bit of a big deal to deploy things. There's still manual steps. The coupling of things is still very this, then that, very interdependent. IAC v3 was the landmark. This is where things really started to gather momentum. We needed to build several performant Mojaloop switches in AWS that needed to consist of sometimes 3 or more environments, and perhaps significantly, we needed to be able to quickly remove them after use. This required us to ensure we had pipeline idempotency, that when code was triggered from, when pipeline, was triggered from GitLab, it would pull the code and deploy the entire pipeline, all the Kubernetes components, the pods, everything would happen idempotently. If you needed to redeploy one part of it, you did not need to redeploy any previous parts of the platform. It enabled us to lean into cheaper components. We were more focused anyway on these rather than availability, as performance wasn't quite such an issue for these smaller deployments. This configuration was highly declarative. Terraform was now in the driving seat, pushing kubespray to deploy clusters and to execute the Helm charts against them. It was a multi-cluster environment though, because we had security and performance concerns around those. This environment would typically mean we could hand over an environment after 5 days. So what does this mean for AAC version 4? Well, it needs to be completely open sourceable. We want to give this back to the community so that other people can use our findings and experience to deploy these platforms. It needs to be aligned with the recommended best practice that we've been talking about previously. And it needs to be simple. There need to be as few tiers as possible. Kubernetes is highly code-centric, which means that deploying IAC in that layer is always preferable. And it needs to deliver us microsegmentation as part of each pod's deployment. And we want to simplify the number of clusters to keep that deployment as simple as well, so that we're not constantly trying to work out communications between VMs. Allow the cluster to do the heavy lifting. We wanted to optimize node sizes to make sure that the cost was controlled carefully, and we want as few VMs as we can possibly afford to run on without compromising either performance or security. And then a sort of a late breaking requirement is also this code should be portable. We're open sourcing it, so it should be able to run on any cloud. Yeah, why do the biggest requirements always come on the smallest post-it notes? There are a number of security objectives that are being baked into IAC v4, such as adequate seam. We've removed IDS as part of the solution because it comes with a lot of very difficult technical challenges. And what we're finding is that actually observable behavior within the Kubernetes cluster is far more valuable and accurate for detecting problems with a lot less false alarms. So those intrusions can be spotted really, really quickly. And there's a project associated with that. We want to drive seam so that behaviors within the system can be observed very, very quickly via the dashboards provided in the management domain. And that we can react to those appropriately, possibly with automation. So yeah, that sort of trend analysis aspect will all be there in Kibana. We also want to ensure that we've got pod security policies and restrictive network policies, i.e. everything is driven on a policy level, allowing for the most dynamic scaling possible. So that post-it note, 4 clouds, customers in Azure, in AWS, and then on premises, several customers have got constraints around compliance where they're not allowed to store data in the public cloud. How is that achievable? Well, we've thought about this quite a lot, and as it turns out that multi-cloud is actually quite complicated. There are a lot of a lot of factors involved. So today, IAC v3 has a unique code base for each provider. Different Modusbox customers in different clouds are using different versions of the IAC. They're not even version synchronized. So, actually working out those disparities can be really quite challenging. There's a lot of work gone into automating Open Nebula deployments, but even then, it's still not fully aligned with the cloud platform. So how do we unify that code base? Well, IAC v4 can be a unified piece of code with modules which we call bootstraps associated with each cloud. These bootstraps are effectively the MAD. So you create a single cluster that deploys the core components of managing and hosting the code and allowing remote access and monitoring and identity. And from there, you spawn the environment using the same code base. That's the objective that we'd like to hit. Whether we can achieve that in IAC version 4 for all those platforms is another question, but this modularization of the platform is something we're very, very keen to hit. This means that once, as cloud providers change their topologies and their technologies, much of this can stay within these bootstrap components in terms of building out different networks and storage and so on and so forth. Meanwhile, the code remains unified and out there in the community. There's limited connectivity between clouds. What this means is that getting from AWS to Azure, if you wanted to stretch, is notoriously difficult. It also means that if you are running in these multiple clouds, although you do have the tools in the MAD for monitoring, your control plane and your cloud management platform is completely different for each one. A number of the on-premises products are aiming to try and address that and become the single plane. OpenNebula is one of them. It was already selected for use on-premises by us due to its incredibly low cost and flexibility, and they are already looking and already have functionality in multiple clouds. So another possibility for a unified code base for IAC is to use one of these platforms to allow multiple clouds to be driven from the same management plane. I've called out on the diagram here that you would need VPNs to operate between these cloud providers. It doesn't have to be VPN, but you are going to need some peer links if you wish to do network stretching or indeed any communication between them of stuff like backups and so on and so forth. However, it does mean that potentially you could run a development environment in one cloud and production on-prem, and then in the event of a disaster occurring, you can bring that environment up on Azure because AWS isn't working that day. This is still highly complex. We have a long journey to achieve this, but it is something we would like to hit. The last thing that probably needs to be spoken about is a more commercial offering from VMware. VMware now have their vSphere platform available in Azure, in Google, and in AWS. Their NSX product allows you to effectively stretch networks between these cloud providers with a minimum of overhead in terms of administration. The initial build out is complicated, but it's then highly reusable. And of course, VMware is a leviathan in the on-premises virtualization space. It also gives you hyperconverged storage and all that other good stuff that means you've got a highly scalable platform. The challenge that they make to the existing platform is that if you are going to run multiple environments in one cloud provider, their pricing is such that it can actually work out cheaper to run 2 environments on vSphere and AWS than it is just to run those environments natively in AWS. Part of this is because environments can rob time from each other, in the age-old time-trusted virtualization way. So at some point during this process, we would like to POC this and start coding out to allow this obviously ubiquitous platform to be consumed. So phasing for IAC version 4. The resource scheduling, container management, and so on and so forth are all things we'd like to cross early on. We're already working on the new ingress, but we believe there's a bit of work to get there, so we hope to complete by phase 2, which will allow us to concatenate the clusters and start using Keycloak to manage those identities. We also hope to start delivering IAC on OpenNebula at that point. As you can see, phase 3 and phase 4 are about managing the K8S and the management domain and building those out properly and integrating Keycloak fully, and also the VMware POC, and then hopefully for a release in phase 4 with customers starting to deploy onto their lower tier environments. What next? A Kafka deep dive. So one of the key points of replication challenges is Kafka and the topics associated with it and how we shard, partition, and so on and so forth. Likewise, database replication. How do we have transitions in 3 availability zones? It's a story in 3 parts and all of them are active. Lastly, geo-replication and Kubernetes applicators. Well, we've touched on geo-replication extensively in this. There's a much deeper dive to be done here around using IAC to resume these environments and how we keep track of data across such a large latency gap. And Kubernetes operators automating for success, having environments heal themselves when something goes wrong, or more to the point when workloads change, having environments deploy or undeploy components to maintain the best cost performance profile, as well as healing itself of difficulties when they occur. And on that note, I'll stop speaking very quickly and take any questions that anybody might have for the remaining 2 minutes.
Thanks,
Thank you,
Steve.
everyone.
I see there were questions in the Q&A panel, but those seem to have been answered. And there's a lively conversation in the chat. I see Jose is on top of that.
I have a quick couple questions here. It did seem that during this discussion at the very end here about the sort of single cloud management layer, that AWS networking seemed to be used all the way across. That seems like an arbitrary choice and would be driven much more by what region you're deploying to. One thing in particular we've seen is that Azure has got far more traction in Africa than AWS does. And so having your choices selecting that independent of the choices you have for the others will first seem to complicate this a bit, but also that the selection of AWS as the network layer wouldn't make sense necessarily. Did I misunderstand that?
No,
I think you were referring to slide 50 might be where I believe there's just a typo. If I got
the last few slides, actually the last several slides also.
Okay.
No, I mean, you're right that it starts from here and it moves all the way through AWS network at the bottom there. It's below Azure subscription. It says AWS network.
Yeah, that's a copy paste error. I apologize.
Yeah, that should be Azure Virtual Network. Yeah.
It would be awesome if you guys could clean up, because this is going to be a super interesting reference, but I'm certainly going to have to stew with it for a while. So that was one. The second is, as we start talking about replication, it's very important that we remember that our persistence layer, which is MySQL and can be replicated in exactly the ways that you've mentioned, is fine. As we say, we will have something like a 1-hour restart lag. That's a catastrophic error. You can probably accept that that level of error. However, most of the recovery we're going to be interested in is going to be at the Kafka layer. That is, what we're looking at is replaying the Kafka stream against the persistent data that we've restored, recovered from. And that Kafka has its own replication strategy for this, but it uses flat files. It doesn't use a database. And so how do we essentially configure this in a way that respects the 25 kilometer latency requirement for getting outside of the ground zero, wherever the bomb hit, and being able to sort of recover that stream and replay it. I think there's some double clicking that might need to be done there to think about that. Maybe I misunderstood the way you're looking at this. No,
I strongly agree. We've been treating the database as a single point of truth, and as such, that's been our key focus for replication. But you're absolutely correct that the more we look at this, actually, the more replication in the Kafka tier actually may supplant that as a possibility. So yeah, there is some more deep diving to do there, which is why I've called it out at the end. Getting that to happen in a performant way is definitely the challenge.
Can I make a suggestion then that you guys tap the Confluent resident architect who is on contract to us to talk about that specific question and say, what are their patterns for cross-region brokering? Because they may have a way of looking at this the same way that you're looking at it, which is to say, we're going to fire this stuff out using a different acknowledgement model to the second region because we can't wait for it. So it's going to be a fire and forget, but the point is that it's going to work most of the time, and the chances that your failure overlaps the time that it didn't work is probably pretty narrow. And so you have the opportunity to probably recover to within a quarter second, maybe a little bit longer than that, from the second region when you need to restore, which means now you're looking at, even in super high volume environment, you're probably looking at a few hundred transactions that have to be recovered. And those can probably just be failed over and said, I'm sorry, your payment failed. In the case that what's going to happen is they're going to time out. And when they time out, a user is going to see that they failed and they're going to have to resubmit it. And that will get us outside of the problem of replication, but it'll also get us outside the problem of duplicate, as Michael pointed out, where we can't resend the same transaction because we will simply say, seen that already, even though we haven't really. we sort of half saw it. Anyway, engaging with the Confluent guys would be great. And then obviously if there are some issues with the deck so that we have reference material, that'd be super.
Yeah, I'll get that sorted today. Thank you, Miller. Good spot.
Thank you.
Thanks, everyone. Thanks, Steve and Jose. We'll move on to the next presentation, bulk payments. This is led by Sam, Rajiv, and Stephen. Rajiv, I'm sure you'd be happy to be a panelist again today.
Yes, please.
That would be. Thanks very much.
All right.
All right.
Do you guys have a presentation?
Yes. Can you see it, Simeon?
Yes, I can. Go for it.
Okay. Thank you. All right. Welcome everyone again for the dark theme presentation. We covered 3 sections out of this yesterday, and we have 2 more. One for day 5, the roadmap, and bulk transfers for now. So as we've covered on the overview section, right now Mojaloop core supports bulk transfers. We saw the resources, the use cases, and all those slides where we provided functionality. Just to give a brief history, we did an initial proof of concept in PI 7. And in the last PI, wanted to make sure that that works, the happy path, and added some tests for that and simulator support. This PI, and we were actually lobbying and trying to influence the community to see if they think bulk transfers is a priority, and finally it got prioritized in PI 10. And we were able to add support for error scenarios for bulk transfers, added the functionality for querying a bulk transfer status using GET, and then supporting the end-to-end bulk codes as well. Apart from that, there was we had to do a lot of work for testing and adding support in the simulators, the Mojaloop simulator, and also the end-to-end tests, the postman collections. Added the link at the end here, the bulk transfer design and processing, where you can see, actually let me, if it is okay, I'll go over to that page and show how it looks like. Can you see my browser here?
Yes, we can.
docs.mojaloop.io. There is a bulk transfers design considerations, high-level architecture, and there are some there are comprehensive details here, not to overwhelm, but to capture everything so that if you see any issues or if you want to do an implementation verification, these will come in handy. Apart from that, we also have sequence diagrams for all of these. We have a bulk prepare, and we can go to all of these handlers, which we will introduce shortly. And then, yeah, see if, get an understanding of how the sequence goes and things like that. Let me come back to the presentation. Okay. All right. Again, I know that most of you are aware of what the bulk transfers looks like with version 1.0, but just to give a refresher, I wanted to go at the high level, go over it at the high level. Bulk transfers 1.0 involves primarily 3 steps. Those of you present on the pre-session or we've been hearing it for like too many times, we have 3 stages. We know that Michael and Miguel talked about it. We have a lookup or discovery phase. We have an agreement or coding phase, and then the final transfer phase. So in the bulk transfer, what happens is the lookup is done by the payer FSP. So lookup payer FSP for individual transfers in the bulk using the participant's resource. The second step is the coding phase, and this is done using the resource bulk codes. But this is also limited to a payer and a payee FSP combination. Meaning at this stage in version 1.0, we can only send to a single pay FSP. We'll talk about the enhancements to that in the roadmap section, which we want to see if the community is interested and then prioritize it for PI 11. The final step, of course, is the bulk transfers, where it is similar to a post transfer, but at a bulk level, which will include the details of the individual transfers. So we have an object that will capture all the individual transfer details needed, such as the LP packet, the amount, the expiration time and PFSP are at the root level, but all the other details are at the individual transfer level. Looking at the sequence diagram from the spec, let me quickly choose an annotation spotlight. So here is the lookup phase. The first phase where we talk about discovery. The payer gives a bulk to the pair FSP, and breaking that bulk into smaller bulks based on PFSP, so rest with the pair FSP at the moment. So the pair FSP does the individual lookup, and then it performs codes using the bulk codes resource based on a pair and PFSP combination. And once the pair gives the go ahead, execute my bulk based on the coding information, then the pair FSP for each of these smaller bulks use the bulk transfers resource in a loop and then executes the bulk. And at the end, we have the bulk has been executed. So it's a transfer phase. Fairly straightforward from a pattern perspective, follows the same pattern as the P2P, which we talked about quite a bit. As part of the implementation, we had to create 5 new handlers to take care of different responsibilities. Before that, I wanted to show something. Let me go back to this slide and show something here and come back to the new handlers. You can see here in the dotted lines, this block here. This is actually the architecture for individual transfer. So the individual transfer includes a prepare topic and a prepare handler, a positions topic and a position handler, a fulfill topic and a fulfill handler, and of course, timeout handler. So we are effectively using the individual transfer infrastructure because it has been proven, it is production quality, it is performance tested, all the good things, all the good stuff. So instead of creating a new infrastructure for bulk transfers, what we do here is take in the bulk, store it in like a limited manner, and then break it down into individual transfers and use the existing infrastructure to evaluate and either commit or fulfill the individual transfers. So let me go back. So in light of this, we introduced a bulk API adapter, which is similar to the ML API adapter, the outward or the outward facing interface, which will accept the requests, and a corresponding notification handler, which will send out the notifications. We have the bulk prepare handler, which accepts the post bulk transfers requests. Essentially, let's say 1,000 individual transfers in a bulk and breaks it down into individual transfers and then sends it to the prepare topic for individual handlers. Similarly, we have a bulk fulfill handler on the fulfill stage. We have one handler here called the bulk processing handler, which kind of lifts a lot of weight here. It is a heavy lifting, does the heavy lifting for bulk processing. It is like the sink, which essentially waits and looks for the completion of every bulk transfer for that particular step. So for the prepare step, it ensures that all the individual transfers reach to that particular conclusion, which will be reserved or either an aborted state, and then takes necessary action, like sending out a notification to the payer FSP or the payee FSP. And we have a bulk get handler, which caters for querying the status of a bulk transfer. Just a quick review, don't need to remember this, but just to show how the state diagram looks like. We have a received state, a pending state, and rejected if it is rejected, either at the payee FSP level or the switch level. But if everything is looking good, we have the following states: accepted, processing, and completed. I just wanted to show these before we go into the architecture diagram so that it will make more sense there. So here is the architecture. It looks pretty loaded, but relatively, I think, straightforward. As if we ignore what we have here for the individual transfers, let's focus on the bulk level. I'm looking for a spotlight again here. So this is essentially the bulk API adapter. Yeah, ignore that. It's a Mojaloop adapter, but a bulk API adapter. First, we have an incoming bulk transfer request, a post on bulk transfers. Receive it in the bulk prepare topic, and the bulk prepare handler then breaks it down into individual transfers and feeds them into the puts or posts them into the prepare topic, the individual transfers prepare topic. One caveat here is that because of the size of these messages, these messages can be pretty huge. These are not like individual transfers which have limited size. We may have 1,000 bulk transfers, which can be pretty huge. And if the size is increased to more than 1,000, then we want to have a mechanism which will be able to withstand that much size of messages. So we added a streaming capability here using an object store. So we take the message, incoming HTTP message, store it in an object store so that it's first stored, and then we send out the accepted. After that, we take care of breaking it down. So we have records records in the object store which are broken down so that it's manageable. So this is the same mechanism we use in the bulk fulfill and the processing stage as well, essentially to help with the size of the messages we're dealing with. So once it is prepared, then again, it goes through the individual transfer architecture or mechanism, and everything is the same there. So once a bulk is received, we mark it as received after it is stored in the object store, and the accepted is sent out to HTTP 202. After the bulk prepare handler breaks it down into individual transfers, we move the bulk into a pending state. And once all the individual transfers are either reserved or aborted, then the bulk processing handler aggregates them, and then it changes the status of that bulk to accepted state. It also sends the notification, which is a post bulk transfers, to the payee FSP. So this is completion of the first leg, first step of the transfer, the prepare step. For the fulfill step, again, let's say in a happy path scenario, or in a scenario where the payee FSP finds that bulk acceptable, it sends out a put bulk transfers ID request, which is like the fulfill. And once we receive that and it is stored in the object store, we change the status of the bulk into a processing state. And then the bulk fulfill handler breaks it down into individual transfers again and feeds them into the fulfill handler. Again, these are aggregated at the bulk processing handler for finalized state. So either they should be committed or aborted. And then the bulk is changed into a completed state after the notification is sent out to the payer FSP. There may be scenarios where there will be timeouts involved. So the bulk processing handler takes care of that as well. The individual transfers may be timed out and they reached an aborted state, and the bulk processing handler takes care of that as well. So this is it. Yeah, go ahead. Yes.
Sorry, could I just jump in for a second? It's also worth noting that in the bulk processing handler on the prepare leg, right? As we before we send out the actual message to the payee FSP, if some of the transfers did not pass, so it failed because of a net debit cap or some other reason, we will only send the applicable transfers within that bulk to the payee. This ensures that the payee doesn't have unusable data within that post. So it's good to keep that in mind because we will be referring to that a bit later.
Yeah.
José.
There are some assumptions we made at the beginning of the implementation for the POC, which are documented in that documentation page that I've shown at the beginning. And we've gone through this, but one thing to remember is that we consider these individual transfers independently, meaning even if there is one transfer that has been committed, we consider that the bulk has been completed. Let's say there are 1,000 individual transfers, and after processing 999, one transfer, which has, let's say, a significantly large amount, breaches the net debit cap. Then only that transfer is aborted, it doesn't go through, and the rest of the transfers go through without issues. So these can be aborted at various levels, either at the timeout level or the payee may give some error information for individual transfers. The error handling is done at individual transfer level, but also at the bulk level. At the bulk level itself, if there is some wrong information given by the payer FSP, then we can cancel it at the bulk level. The payee FSP also has an option to reject it at the bulk level by sending an error callback, a put bulk transfers ID /error, as usual. I think what Rajiv brought about is pretty interesting here is that typically on a GET, when we want to query a transfer, what happens is the payer and payee FSP see the same information for a given transfer, that is for individual transfer. Only the payer and payee FSP can see the information for individual transfer, but even then both of them see the same information because essentially it's a single transfer. However, in the bulk case, it's a little bit, it's not as simple because let's say when we get a a bulk with 1,000 individual transfers. And as I've indicated earlier, only 999 of them were able to be under the net debit cap. So sending that single failed transfer to the payee FSP makes no sense because it can do nothing with it. You cannot fulfill it, and it's just instead of being unuseful information, it is more confusing information. So we decided that we are not going to send that to the payee FSP. And this is something we also brought up during the initial POC and the later standardization, that this will have to mean that we need to use hop-to-hop encryption in this case. So that's a big consideration to be done for whoever is adopting this. And the similar thing applies to the GET. So the payer FSP, when it does a GET, it essentially sees the individual transfer status or results of all the 1,000 individual transfers. However, when the payee FSP checks for the status of that bulk transfer, it only sees the results for the 999 that it saw initially. I see some questions, so I'll go ahead with answering those. Let me stop sharing, and Stephen here on the call should be ready with a demo, and I'll look at the questions in the meanwhile. Stephen, please go ahead.
Oh, thanks. Thanks, Sam, for doing the heavy lifting. So I'm just going to share my screen and do the demo. Can you see my screen?
Yes, we can.
Yeah.
Okay, thank you. So the test suite here for the bulk transfers has just two scenarios, the positive and the negative. The positive is just the happy part. We're sending a bulk transfer containing 2 individual transfers, and we expect the 2 individual transfers to be successful. So for the negative scenario, we're testing 2 scenarios. First is when the payee FSP aborts the entire bulk transfer. And the second one is if we have a situation of partial fulfill where out of the 2 transfers, one of them was successful. So there are some details which I think Sam just explained. So I'm just going to quickly run through all of the scenarios and then go through the results one after the other. Okay, that went well. So I'm gonna open this up and then we can inspect the tests. So this, if you look here, suggests the header validations, which we expect to be successful. So on the payer side, the callback, the bulk transfer state is completed. Of course, because the 2 transfers are positive and they all went through. For the payer FSP, we have individual transfers, so both are successful. So the first transfer should have fulfillment, and then the second transfer also should have fulfillment. The same results is also seen for the payee FSP. The bulk state is completed. The first transfer is having a fulfillment, and same for the second transfer. These are the validations for the requests. We're not going to go into that. So now all of these tests here are just broken down here for the payee FSP and the payer FSP. So the payee FSP here is doing a get on the bulk transfer, and then it's getting these results, which I've also gone through here, and also the payer FSP. So they are seeing the same result because the 2 transfers were successful. Now for this scenario where the PE aborts, so here we're just trying to ensure that the position of the PRFSP is not tampered with when the transfers are aborted. So here, the callbacks should be different for both the payer and the payee FSPs. So here the payee is sending back an error, 5100, an error description, an error code. So we expect to receive that callback on the payer FSP side. And then also for the payee FSP, a message is also sent back to the payee FSP with the error code and the error description. So that is for the partial for the PE aborts scenario. So here you can see that the PE position after the abort is the same as the position before the prepare. Then for the partial fulfill scenario, here one of the transfers goes through and the other one fails. The states for the payer is still completed as described by Sam. And then, so for the payer, all the transfers are returned, both the failed transfer and the successful transfer. And then one of the transfers is successful, and then the other one contains error information. But for the payee, the transfer state is also complete, but only one transfer is sent back to the payee, is forwarded to the payee rather. And then that transfer is expected to be successful. So the payee doesn't get the other failed transfer. And also the request to the payee FSP contains only one transfer because the other transfer fails at the switch validation level. So when the payee FSP does a lookup for the bulk transfer, so the same thing, I'm just going to repeat the same thing that has been said here. So you only sees one individual transfer in the callback, whereas the payer sees the two transfers. The two transfers. So one contains the fulfillment and the other one contains error information. So I think that's a wrap for me. Any questions?
Thank you, Stephen.
Okay.
Yeah, Miller. So currently it's at the schema validation level because we have it defined in the Swagger. As
Sorry, Sam, could you repeat the question? I don't think anyone could see it. It was on the panelist side only.
So the question here is, thank you. The question here is, what are the limits on the bulk batch size? Do we enforce it at the switch and conform to the limit on sending to the payee DFSP? So the authors of the API definition, we did some calculations of the message sizes, adding all the option elements and going to the max limit. And we came up with, I think, around 5 to 15 megabytes for each message for a bulk transfer. So wanted to keep it to 1,000 for the time being. And if there is more, if there is community interest, we can look at other options, increasing it to more than that. But yes, currently it is 1,000 and it is enforced at the schema validation level, meaning if we send more than 1,000, the request will fail synchronously immediately with something like a 400 error saying syntax issue.
That's great. So you basically, when it's passed into the system though, you said you were going through an object store stream. Mm-hmm. So you would be looking at that byte by byte, and when you hit the byte limit, you'd have to fail the stream input at that point. It wouldn't be that you submitted a 25 megabyte bulk size, having to take all those bytes in and then say, oh, by the way, it's too big, because that, of course, would have wasted everybody's time. So it's going through a stream interface, and at the point at which it exceeds the stream interface limit, you would simply fail it at that point, say it's too big.
Yeah.
Okay, so then the next question that flows from that then is, obviously this needs to be configurable, but within limits, because a scheme might want to set these sizes, but we want a design limit that our performance assumptions and deployment assumptions can fit around, where we can make some statements at the system level that say, if you deploy Mojaloop, this is what you get. If there's a scalability point for the bulk, that would be useful to know. So is there parallelism, for instance, that could be applied at the bulk level to where a DFSP could submit 2 or 3 bulk batches at the same time? Is that anticipated?
Yeah, so we want to consider that as a roadmap item. I think initially when we discussed with the community in one of our in-person events, what we understood was that typically bulk batches are thought of in tens of thousands or more.
Oh,
so,
easily.
Yeah, we definitely want to look at that, but it will involve, like, as you said, multiple messages, even on the belonging to the same bulk. So we want to support that.
So I'd tag, I'm going to tag Pedro on that one, and that you guys probably should have at least a high-level conversation about what impacts if the POC is adopted as an architectural pattern. Have at least a high-level conversation about the forward work we would have to do to conform the bulk system into a similar kind of design thinking. Obviously, it won't be exactly the same, but there would be some way of thinking that through that. As the parallelism occurs at the batch level for bulk, there appears to be a similar system we could apply here.
And one other thing I wanted to share is that we are in fact shielding the individual transfer infrastructure by having this streaming capability, so that we can still use it while protecting that from the size of the messages.
I see. Okay.
Yeah, that way the intern, like everything else we are using here, the Kafka handlers and the individual handlers themselves are protected, and we have the streaming here, which takes care of that.
Miguel, yeah, it's just also one of the key aspects as to why the object store is included there is Kafka is not very good at dealing or handling huge messages of, like, so
that's right.
Once you get bigger than a meg, you have problems. That's also why the object store is there.
Yeah, that's exactly right. And so I guess my question, and this is an open-ended one that may not have a direct answer, but whether we at that bulk level, when you've acquired that bulk, whether you break bulk and process those messages individually as individual transfers, but tagged with some kind of bulk context, where it can be reassembled later, but that they can be processed through the system essentially in parallel, or at least concurrently, I should say. They can be handled concurrently.
Yeah,
that is exactly
we do tag them with the parent bulk ID. Yeah.
So that way they're concurrently handled, because in the case where, even if in the case where they're all going to the same DFSP, which is the way you've asked them to be coded at present, the individual line items may have different processing time on the payee DFSP. We can't say for sure what they did when they quoted it. They may have decided it was a high risk transaction and they segregate it in some way, we don't know. So then when they come back again, you do have to you have to assemble all of those transactions before you both respond. Is there a possibility though that you will have a separate, I don't know what to call it, timeout at the batch level, so that when you send that batch of 1,000 fulfillments, or sorry, excuse me, 1,000 prepared transactions to the payee FSP, you only wait a certain time for the 1,000 fulfills to come back?
Yeah, we do have the timeout for the bulk codes and the individual transfers at the root level, so it applies to the whole bulk. So
the timeout is at the bulk level, and it applies to all individual transfers within it. They don't each carry their own separate timeout.
Correct.
Okay.
So the other benefit to that is that if a payee FSP ideally should not be doing this, but if they want to only fulfill like 500 of the transfers and ignore to send the other 500, they will be handled by a timeout handler and be aborted anyway.
Yeah, and obviously that's the right way to start, but then I think you want to get more nuanced and say there's a way for them to actually signal that to you, that they didn't have time to do all 1,000 you asked them to do, so they did the 500 they could do, and the other ones were specifically ignored. and should be resubmitted then as it's a temporary failure, as opposed to not understanding them and not processing them and allowing them to time out all the way back to the payer.
Yeah.
Yeah, there's a problem here, isn't there? In that, if you imagine a payroll, it's okay not to pay people who don't have correct identification or can't be paid because their account isn't in good status. But I think it's probably not okay to pay half of the people and not the other half.
Yeah, but the switch is not making the call. The employer or the entity who's paying is making that call. So it's up to them. The switch fulfills if they want to fulfill everything. The switch is
but Michael, you're right. I think your point is well taken. That it's not a choice that is being made arbitrarily by the payee DFSP. It is a technical competency choice that says, you asked me to do 1,000 things inside of 10 seconds. I can only do 500 things in that time period, so I did them. These other things should be resubmitted to me, and that's a switch command. It doesn't go back to the payer. The switch simply resubmits those 500 immediately. They can then be reprocessed, as opposed to the 500 I didn't process are considered permanent failures for exactly the reason you stated. Their account's not in good standing or what have you. And so we should signal the campaign manager that these can't be processed. Those would be different qualities of failure, I think.
Well, that should apply though universally to a single payment or bulk. If you think that's a valid case, then even on a single payment, you asked me to do this, and I can't do the one payment in the amount of time allotted. So that would just need to be a standardized error or valid response.
Well, that's possibly true, but not quite, because the reason I can't do it right now is you asked me to do 1,000 of them, and I can only do 500, as opposed to you asked me to do one, and the time you gave me is always going to be inadequate.
Yeah, but you asked me to do 1,000 in batch. You're asking me to do 1,000 in a second. The same thing can happen. It's just one's happening as one message and one's happening as 1,000 messages. And if you think it's valid to reject a message with a thing that, hey, please resubmit this because technical reasons mean I can't do this before the timeout, then it should just be a thing, and then people would use it if they had to, right?
Yeah, I was making a point. It's a very high-level question that needs to be analyzed. I'm not explaining it at a narrow enough level. You're addressing a much narrower question. So I think that it's something that needs to be looked at, the difference between a temporary failure between the switch and the payee DFSP versus a permanent failure of a transaction. Whether it's a single transaction or multiple is a point well taken. We could have the same issue with singles as we have with bulk. Bulk has a special consideration though, because we are processing a bulk that has to have a single response back to the payer DFSP.
And with a single transaction, it's probably the right thing to do to send that back to the payer and say, sorry, wasn't able to do that. Would you like to resubmit, or do you want to ask your person if they want to resubmit? That kind of thing.
I think you're right, Michael, but yet I'm not sure of the exact narrow circumstances. But anyway, so to both of you, I would agree that what happens on the bulk level probably also happens at the single level, and we should think about it. But I think that the cases are different.
Good flexibility, Miller. I'm impressed.
Sorry.
and it goes without saying, but I think this should be covered as part of scheme rules, like assigning more time for bulk transfers processing. Things like that as well, and how to handle, like the scheme may mandate that the payee FSP should mandatorily respond to all the individual transfers that it had been submitted, whether it's fulfilled or aborted. Even if it doesn't have the time, it should at least say, okay, error information and the detail of that error. So that can be mandated. And I'll talk about those in the roadmap here. I just want to quickly touch on Istvan's question as well from the chat. In the Payment Hub Enterprise Edition, we will be working on the bulk payment. The question that is pre-processing to split a batch to separate bulk files for DFSP and getting the codes and send them one by one is a possibility. Or we could wait for the mixed bulk extension without making commitments. Do we have a plan for the extension or not? So this one, I think this has been one of the things that has been brought up. We brought up in the previous convening and the one before that as well. It seems like the community is leaning towards making it simple for the FSPs, where the switch takes the responsibility for dividing it up and doing the lookup at the bulk level and maybe even doing both the lookup and the code, and then giving the code aggregated code to the pair FSP. So I would say let's add it to the roadmap and see what comes up, like at which priority this comes up. But if you're interested in taking this up, maybe you can add that as well in the roadmap and add yourself as an owner to the topic. But I would say definitely let's discuss that tomorrow as part of the roadmap.
Can we figure out the right forum in which to discuss the point that Michael, Brian, and I are discussing on the error flows through the system? Because I think I heard what you just said actually triggered another concern for me on the same thing, that we owe the payer DFSP an answer on all 1,000 transfers. That concerns me, and that if I said, oh wait, no, because we're going to resubmit 500 of them, we still have some time left. But then we come back and we end up putting all 1,000 at risk, even the 500 that we could have actually committed successfully. That there's something there that's doesn't feel quite right. That is whether we expect the payer DFSP to fully process the entire 1,000 batch in a way that is completely responsive to the payer DFSP, or do we expect there is some kind of retry or strategy or something in the center? I guess I'm not sure yet. Something's not there. That's not right.
Okay. At this stage, we are not doing any retry, Miller. So we just give it to the
That's
PFSP,
fine.
and what are the PFSP response will take as an answer.
Yeah. So what we have, right, of course, is that you've done payroll. It turns out that say 500 of these are on some dinky little MFI somewhere, and the largest bank in the country decides to send 500 of those to that, and they've set a timeout on theirs according to the SLA given to them by the scheme, and this tiny little guy gets these 500 and says, I can't possibly do all 500 of these in the time I was given. So there's a mismatch, basically. Something has to be addressed there that allows the payee DFSP to reflect its skill and capabilities into the system that can be either the system is responsive to in breaking bulk, or the payer DFSP is responsive to through scheme rules when it submits the bulk in the first place. There's a discussion in there somewhere. I don't want to do it now, but
yeah. If it gets prioritized, yeah, we can discuss that in the roadmap.
Okay.
So yeah, there are a couple of things I think which will ease the burden on the FSPs, at least doing the bulk, such as bulk lookup and another comprehensive bulk make. And then again, I also added a step 3 here, using configurable options such as all or nothing. It kind of relates to the split payment capability we talked about, but we can discuss these in the roadmap. With that, I will wrap this up. I'll continue answering on the Q&A and chats if there are any questions. Thanks for the
Thanks
questions,
so much.
Miller, Michael, Brian, Simeon, thank you.
thanks, guys. This is great.
Thanks.
Really nice to
Thanks
see
so
the
much.
progress on this bulk.
Yeah, thanks so much for all the feedback and engagement. We're on to break time. I will give you a full 9 minutes up until half an hour, 30 minutes past the hour. That should give you enough time to order yourself one of Miller's delicious Miller's burgers, as Michael recommended. So we'll see you guys 30 minutes after the hour.
I'm sorry to say, chaps, I ate them all.